Number 40. Complete the following table for the two most widely occurring isotopes of the element mercury, Hg. Compact fluorescent bulbs each contain about 4 milligrams of the toxic metal mercury, so used bulbs should not be discarded in the household trash. So this last sentence is just an interesting piece of information about mercury. The first sentence says what you're supposed to do. So you're supposed to complete this table down here. Let's take a good look at the table. So there it is. Now you're given some isotope symbols of mercury. Here's mercury 202 and here's mercury 200. Just a little background on isotope symbols if you need it. Isotope symbols can be used to identify how many protons, neutrons, and electrons are in a particular atom. And isotope symbols look kind of like this. I'll highlight this in yellow right here. So they look kind of like that or like that. Now these two isotope symbols are really the same thing. The bottom left-hand number is redundant. It's not needed. So you could get rid of it and just write the isotope symbol that way. But sometimes you see the number on the bottom left. Now what these two numbers represent, the top one is the most important one. It's the mass number, and it tells you protons plus neutrons. The bottom number just tells you the protons. Now the reason I said it's redundant is because anytime you have a carbon atom, it has 6 protons. So anytime you see the capital letter C, that is synonymous with 6 protons. That's what it means to be a carbon. Okay, the bottom number is the atomic number, and the atomic number of carbon is always 6. It never changes. Okay, but the mass number can be different. There are different isotopes of carbon, and that's because some carbon atoms have 6 neutrons, some of them have 7 neutrons, and so that leads to different carbon atoms having different mass numbers. Okay, so this is redundant down here, and we could just write it like that. Now, if we want to identify how many protons, neutrons, and electrons are in this isotope or that one, first of all, we know that carbon has 6 protons. You can find that on the periodic table right here. Go look up carbon right there. It's element number 6, and that means 6 protons. Okay, so no matter what, there are 6 protons. The way to get neutrons is to take the mass number and subtract protons. So you take protons plus neutrons, you subtract protons to get the neutrons. So 13 minus 6 would give you 7 neutrons. And if it's a neutral atom, which it is, unless you're told otherwise, then the number of electrons always equals the number of protons. So there are 6 electrons here. Now let's go to the isotopes of mercury. Mercury is one of the 2 liquid elements, and here it is, number 80. Okay, so these 2 isotope symbols over here, mercury 202 and mercury 200, we could write those as follows. So mercury 202, and then mercury 200. If we want to include the atomic number in the isotope symbol, we can totally do that. Okay, it's not needed, but we can put it there. Because anytime you have mercury, its atomic number is 80. These two are synonymous. Okay, now remember, the top number is protons plus neutrons, and the bottom number is protons. So to fill out this table right here, the bottom number is protons, and protons is the same thing as atomic number. So here, let me rewrite the important information. The particles are protons, neutrons, and electrons, but protons is the same thing as atomic number. The number of protons is the atomic number. Okay, so for the for this one, the mercury 202, well, mercury has an atomic number of 80, so I'm going to write that here. The atomic number of mercury is 80. It doesn't matter what type of mercury it is. Okay, it's 80. So it's 80 for this isotope and it's 80 for that isotope. Now the mass number is the number upstairs. That's remember, mass number is protons plus neutrons, and that's the number upstairs. So mass number, I'm gonna just, draw a little arrow. Those are the numbers upstairs. So that's 202. 202 for this one, and it's 200 for that one. To get the number of protons, that's the same thing as the atomic number, right? The number of protons is the atomic number. So we've already got the atomic number, just copy that down, and that's number of protons. To get the number of neutrons, you take the mass number and you subtract the protons to get the neutrons. So 202 minus 80, what's that math? That's 122. 122. And then 200 minus 80 is 120.